Hello friends, in this video we will discuss the leftover topics in the number. We just left over with the decimals, fractions and the number conversion from one form to another form like binary to hexadecimal, hexadecimal to binary, octal, etc. So without getting late, just get into the decimals. By starting with decimals, we know the decimals are the floating point values. It's just similar to the float point value, but compared to floating point values and decimals, the difference is the floating point values has not set correct precision, exact precision, that means accuracy, whereas decimal has the fixed precision that we give defined by the user. So for example, if we look over like 0.1 plus 0.1, 0.1 plus 0.1, we get the output like 0.3 something float value and number. In order to avoid this, we just use the decimals, so this has the more precision. So if you print like 0.1 plus 0.1 plus 0.1 minus 0.3, what will be the output of this? So it must be 0, but it will not be 0 because here it is like floating type and it has no good precision. So for this we will use the decimals. So for this we need to import the decimal module. So this is the decimal module, and we can import like from decimal we will import decimal, and now we can print like decimal of 0.1 and copy it. So when we run this program, we get the output like 0.00. So here what we did is just we took the exact precision that given by the user, like we give the 0.1 and the decimal of it will be 0.1. So 0.1 plus 0.1 plus 0.1 is 0.3. So it is subtracted by 0.3. So we can just simply see like so we simply run the decimal of 0.1, so it gives like 0.1. So here we imported the decimal, like from decimal module we imported the decimal, and we can also import like import decimal. So if we import like this, we need to call again the decimal module, like decimal, we will print like decimal dot decimal. So we need to call like this if we just import like decimal. So in this we pass like 1 and divide it by 7. So when we divide the decimal of 1 by decimal of 7, that is 1 by 7, we get the output like a float value like this 0.1 something. And if we check the type of it, it will be the type of decimal. This is the decimal type, I mean the class of it will be decimal. And next, if we want to precise like we want the up to decimal points of 4 digits, we can also specify by using a object like decimal dot get context dot precision, that is equal to 4, and setting it up to the 4. So by using this object we will get like up to the 4 decimal points 0.1429. So next we will jump into the fractions. So the fractions are nothing but it's which have the numerator and denominator, that is in the p by q form. So for this we need to import the fraction module. So from fractions we need to import fraction. This is similar like decimals. So let us take a variable like a that is equal to fraction of, we need to pass the numerator and denominator by comma separated values. Let us separate by 1 comma 5, and if we print the value of a, we get the output like 1 by 5. So this is the fraction form, and we can also check the type of that fraction. It will be fraction dot fraction. So this is the class fraction. So we can do mathematical operations by using these fractions. Like suppose we have another expression like we assign it by b and c is equal to a plus b. So let's print the c. So we will get like 5 by 5 that is equal to 1, and when we print it we got the output like 1. And we can also multiply, we get like 6 by 25, and similarly division we get the same. We can also create the fraction from floating point numbers in the form of strings, like fraction of a string number like 0.25. So when we run it we get the output like 1 by 4. The given floating point will be converted into the fractional form. And we can check another example like also 125, we get the 5 by 4, and we can do addition between them and subtractions. So we get the output like 5 by 2. So if you want to return this fraction in the form of tuple, like, so let us take 1.25. So fraction of 1.25 will be 5 by 4. So if you want to get that fraction like a tuple, so we can use the object like, we have a method, and that is 1.25 dot as integer ratio. So when we run this we get the tuple formed fraction type. So we got the 5 comma 4, and we can check it also. The class type will be tuple. So we discussed that about tuple in the next videos. So next we will jump over the complex numbers. So we already discussed about the complex numbers, and we just go through it. So if we took 1j into 1j, so we should get the output like -1. So when we run it we got that -1 as the real value, and the 0 is the imaginary, this is j is the complex. So we got the complex number, and if we print like 2 plus 1j into 3, we got output like 2 plus 3j. So if you multiply 2 plus 1j into 3, so we get output like 6 plus 3j. So all the complex operations can be performed in this also, and the complex numbers are mostly done by or used in the engineering and science applications. And next we get into our last topic about the number conversions. So in this we convert the numbers from one form to another form. So first of all we just look over the notations. So in order to, the octals are represented by 0 0 0 1. So here the O is nothing but the octal, and 1 is the octal number 1. So when we run it we get the output like 1. So this is the octal form number 1, 0 0 2 0 and 0 0 377. So the octal numbers for those are 1, 16 and 255. And similarly it is same for the hexadecimal numbers like, so hexadecimal is represented by cross symbol, that is x, and when we run it we get the hexadecimal converted number like 1. And if we give the input like 0xff, so we give the input as the hexagonal and we get the output as integer 225. We get the output as 225. Similarly, we can also convert from hexadecimal from the decimal numbers to the hexadecimal. Like if you print octal of 64, we pass the input integer like 64 and we get the output as converted octal number, that is 00100. It is the equivalent of 64 in octal. And similarly for hexagonal, and when we run it we get output like 0 cross 0x40. And similarly we can also do it for binary numbers. If we pass 64, we get the binary equivalent of 64, 100000100. So if you take small number like 8, we get like 1000, and like 7 we get all ones, 111. So this is the equivalent number, binary converted number. So if you want to convert the given in any kind of integer into the base 10 form, that is normal integer number, so we just see some example like integer of 64. So when we run it we just get like 64 as the output, and I separated by comma. So this is the normal number. We found that integer of 64, and if we write like integer of 100, and the 100, and I separated it by comma and I passed it as C8. That is, we took the input as the string 100 and it is converted into the 8 base 8 form. So we get the resultant as the integer output by converting that by doing type conversion as integer. So when we run it we get the output as 64. And similarly for hexadecimal we can do like integer of, we pass like 40 comma 16. So for this is for the hexadecimal. And for binary we should use like 2, base 2 method. We get the output as 128. So now we will just go through some of the bitwise operations. So suppose we take x is equal to 1. So the binary equivalent of 1 is 0001. So if we want to do left shift operation, that is we need to print x of left shift is denoted by double left arrow, and we need to shift it by 2 times. So the output we get like, if we took this example, so here we had 0001 as the input, and if we do left shift of 2 times we get like 0100. So the value of 0100 will be 4. So when we run this we get the output like 4. And if we want to do bitwise OR operation, we take like x, this is the bitwise OR, and we OR by 2. So we take another number y is equal to 2, and we pass the y, and the equivalent number y is equal to 2, and the equivalent binary number for 2 is 0010. And if we do OR operation between these two, we get the output like 0011, and the output will be 3. The equivalent number of 0011 will be 3. So when we run it we get the OR output as 3. This is the bitwise OR, and we can do similarly as bitwise AND. So bitwise AND operation, the output will be 00. It will become 00. So our output will be 0. Suppose we change it like 3. So this will become 1 and this will become 1. So output will be 1. So we can also do the left shift or any bitwise operation by using this binary numbers also. Like we take x is equals to 0b 0001. So this is the binary equivalent of 1, and if we print the left shift 2 times, so we get the output like 4. And we can also do OR operation, like we OR with something binary number like 0b 010. So 0010, and if we OR between this x and value of 2, so we get the output like 3. Similarly, we can do AND operation, and we end it by doing some XOR operation. Suppose we have a number like 0f 0xff. This is the hexadecimal, and if we just print x, we get the output like 255. And suppose we want to convert it to binary, so we will convert into binary of x. So when we run it, we get the binary form. We take a variable like a, that is equals to 0b1111. We take a variable like b is equals to 0b0101. So we print the a XOR b. So the XOR operation will be like, suppose we take in a comment like 1111. So this is the binary equivalent, so I am writing simply site, and the binary equivalent of this is 0101. And when we do the XOR operation between these two, so actually the XOR will perform like, when there are same inputs, the output will be 0, and when there are different inputs, the output will be high, that is 1. So here we have MSB like 1 and 0, so the output will be 1, because these are different, either this and this will be different. And here if we see the next bit, we have 1 and 1, so the output will be 0, and for this 1 and for this 0. So 1010, the equivalent number, binary equivalent of this 1010 is, so when we run it, we get the output like 10. So that's it for the video. Hope you like and subscribe. See you in the next video. Thank you.